In this video, I want us to talk about acids and bases. So we have two theories that we're going to base our definitions on: the Arrhenius Theory and the Lowry Bronsted Theory. So under Arrhenius Theory, an acid is a substance that produces hydrogen ions, while a base is a substance that produces hydroxide ions. But that's very vague. Let's go ahead and take a look at how that actually looks like. So, Arrhenius Theory: an acid produces hydrogen ions. Let me show you what I'm talking about. So, for instance, let's take HCl as an example, and then plus H2O. What are we going to get? We're going to get Cl minus plus H3O plus. This presence of H3O plus is what we refer to as hydronium ions. But the definition says hydrogen ions. So why are we now talking about hydronium ions? Well, they, for the most part, treated the same. Take a look at this. HCl can give us H plus plus Cl minus. So if a substance produces H3O plus or H plus, then it is considered an acid. It produces hydrogen ions or hydronium ions. So this is how we define an acid under Arrhenius Theory. Let's go ahead and take a look at a base once more. So we said that a base is a substance that produces hydroxide ions or OH minus when it dissolves in water. So let's go ahead and take a look at that. So which base can we use? Let's take NaOH. We're going to come across this base so many times. It is sodium hydroxide. So NaOH, let's dissolve it in water. What are we going to get? We're going to get Na plus plus OH minus. This is a base. When dissolved in water, it produces hydroxide ions. Do you understand what is going on?
Not really, especially on acids.
Okay, what is the issue there with the acids?
Okay, so it was said that HCl plus H2O give us H3O plus Cl minus, right?
Yeah.
So here he said HCl gives us H plus Cl minus. Does it mean that the H plus that HCl gives is dative covalently bonded to H2O?
Oh, yes. Yeah, that is grade 11 knowledge right there, covalent bond. I forget about that sometimes. Yeah, I think we can say that. We can even go ahead and draw a low structure diagram and see if we're gonna get H3O plus. But I know this to be true. It's just that in grade 12 physical sciences, we don't even think about it. We just know that HCl plus H2O will give you Cl minus plus H3O plus. So these two equations, they're gonna lead to the same consequence all the time. So whether in an exam you decide to use this equation 1 or you decide to use this equation 2, the consequences are going to be the same. That is going to be clearly demonstrated when we solve some problems. Can you take a look at the second definitions? Okay, Lowry Bronsted Theory. This is actually the easier between the two. Arrhenius Theory, well, it's still easy, but Lowry Bronsted Theory is relatively easy compared to Arrhenius Theory. So what does Lowry Bronsted Theory say? Let's take a look. An acid is a proton donor and a base is a proton acceptor. That's it. That's the definition. You can come across this in the exam for 2 marks. What is an acid? And then you say proton donor and then you get 2 marks. So 1 word, 1 mark. And then a base is a proton acceptor. Alright. And then obviously, if you talk about the acceptance of a proton and the donation of a proton, then we go ahead and talk about what we refer to as an conjugate acid-base pair. We talk about what we refer to as a conjugate acid-base pair. Okay, but before we can just talk about acid conjugate base pairs, let me just show you what we're talking about when we say that an acid is a proton donor and a base is a proton acceptor. Maybe before we can do that, tell me, is H2O an acid or a base?
It is a neutral substance.
Okay, right. Most of the time, if it is reacting with an acid, it is going to act as a base, and then if it is reacting with the base, it's going to act as an acid. And we can show this idea of an acid being a proton donor and a base being a proton acceptor clearly using a reaction between an acid and a H2O, a reaction between a base and H2O, and even just a reaction between a common acid and a base. We can still demonstrate that fully well. So let me show you what I'm talking about here. Let's say, for instance, we have HCl plus H2O. There we go again, to give us Cl minus plus H3O plus. Okay, so take a look at this definition. An acid is a proton donor. What do we mean by proton donor in our case? H plus. And the base is a proton acceptor, H plus. So take a look at HCl. We start with HCl, and then now we have Cl minus. So what has happened there? From HCl to Cl minus, what has happened there? Well, we had a proton, we had H plus, and now it's no longer there anymore. It would imply that this HCl is an acid because it is a proton donor. It has donated a proton. It was HCl, now it is HCl, it is Cl minus. Initially it was HCl, now it is Cl minus. So clearly it has donated a proton. So we would refer to it as an acid.
Okay, does it mean that to classify a species as an acid or a base, we do not consider the hydrogen?
You'd have to explain to me what you mean by that when you say we don't consider the hydrogen. In this example that we have, what is leading you to say we don't consider a hydrogen when we consider a species an acid or a base?
Okay, it is because to consider HCl an acid, we spoke about Cl being negative, and we did not talk about H being positive.
Okay, our definition is that an acid is a proton donor. So the only reason why we're saying that HCl is an acid is because it has donated a proton. Because take a look at this. HCl is made up of H plus and Cl minus. So this is HCl, right? And then after it reacts with H2O, we now have Cl minus plus H3O plus. So it has donated a proton. That's why we're referring to it as an acid.
Okay.
Okay, so let's get rid of this. So HCl in this case is our acid. Okay, and then if this is an acid, then the H2O will act as a base. But is it clear that it's a base without putting that into context? What is a base? A base is a proton acceptor. So tell me, does H2O accept a proton?
Yes.
Yeah, it accepts a proton to become H3O plus. So because it accepts a proton, we refer to it as a base. That's it. That is Lowry Bronsted theory. So HCl is an acid because it donates a proton, and H2O in this case will be a base because it accepts a proton. Right. So that is acid, that is base.